And then let's look at this. And just remember, if you have questions, just interrupt me. It is not mean to interrupt me, or I'll pause and ask. But if you do, like if you get stuck somewhere, please just interrupt me. Just unmute yourself and interrupt. So double and half angles, this is the last of the identities that we're going to do. If we were in class, we would have gone way more into this, but it's just kind of, we don't have any control over this right now. So here are these double angle identities. Again, you don't have to memorize these, okay? The very first ones that we did, the Pythagorean identities, the reciprocal identities, those ones are the ones you need to memorize. These ones, I don't care as much about. Just like have them to reference, okay? So here, if you, this is what your questions will kind of look like. So if sine equals 3/5 and its theta is between 0 and pi halves, we want to find sine of 2 theta. Well, this part right here, this 0 to pi halves, that tells us which quadrant the angle's in. So if we think about like a unit circle, or not a unit circle, just like a coordinate plane, 0 to pi halves, that's the first quadrant. So that means that this right here is in the first quadrant. Okay, and you can draw any triangle. Like I drew mine so that they were correct sizes and everything, but when you're doing this, you can just draw any right triangle in that first quadrant. Let me move this. Okay, and then sine, if you remember back to SOHCAHTOA, is opposite over hypotenuse. So here's our angle. The angle is always with the x-axis, always with the x-axis. It's where the reference angle is, like if you remember back to when we were doing reference angles. So that means the opposite side from here is 3, and the hypotenuse is 5. Which then, I would just solve this triangle because it's an easy one. It's a 3, 4, 5 triangle. But if you use Pythagorean theorem here, you can solve for this side and you end up getting 4. Or if you remember, there's like certain Pythagorean numbers. 3, 4, 5 is always going to be one of those Pythagorean triples. Okay. Are we all okay with that? Is there any questions to there? Okay. So then if we're finding sine of 2 theta, well, that means I need to use this right here. That's the only one that's going to give me sine of 2 theta. And by looking at this, I know I need sine, which I already have, but I also need cosine. So to find cosine of this, it would just be 4/5, because cosine is adjacent over hypotenuse. So that's the adjacent side. That's the hypotenuse. And then these are just numbers, which makes this a little bit easier. You can just plug them in. So that's going to be 2. Sine of theta is 3/5. So that's where I got the 3/5 from. Cosine of theta is 4/5. And then just multiply this out. And I think I just used my calculator. Even if you don't, like 3 times 4 is 12, times 2 is 24. So it's going to be 24 on top. 5 times 5 is 25. So that means sine of 2 theta is 24 over 25. And then that's it. That's all you're doing here. And this gets useful once you get into calculus. Right now, it's just getting the steps down so that when you do see this stuff in calculus, you're able to just do it. Okay. Any questions with that?
I have a question, and this might be dumb, but where did you get the 4 from when you were drawing the triangle on the graph? Where'd you get the 4 from?
So if you do this, you see where I got the 3 and the 5, right?
Yeah.
So just set up Pythagorean theorem. So just do like 3 squared plus 3 squared equals 5 squared. And then solve it and you'll get 4.
Okay, that makes sense. Thank you.
Good question. Any other questions with this? Okay, let's do this one. So if tangent equals the square root of 3 and theta is between pi and 3 pi halves, we want to find cosine of 2 theta. So first, this tells us that it's in the third quadrant. Okay, so it's down in this quadrant right here. And if tangent is square root of 3 And tangent is opposite over adjacent. Well, this, we don't have like a fraction here, so we can just put this over 1. So if there's theta, I'm going to say that tangent is opposite over adjacent. I need to write some stuff here. So let's see. So if we have tangent, okay, I'm just going to write t of theta equals the square root of 3. Whoa, sorry. What the heck just happened? All right, anyways, tangent of theta equals the square root of 3. I need this to be a fraction, so I can put this over 1. So it'd be square root of 3 over 1. And then since this is in the third quadrant, that means this goes left and it goes down, which means that both of these need to be negative. So the opposite side is going to be negative square root of 3. The adjacent side is going to be negative 1, because a negative divided by a negative is a positive. Does that make sense? Are we okay with that? Okay, hopefully, fingers crossed. Interrupt me if it doesn't. But then same thing here, use Pythagorean theorem, and you end up getting 2 as your hypotenuse right there. Okay, because it would be square root of 3 squared plus 1 squared, which would be 4. Square root of 4 is 2. Okay, and we're finding cosine of 2 theta. So I can use any of these right here. Does not matter which one you use. And if you want to like double check with yourself, I'm going to use this last one. But if you wanted to do this and use like the first one, you should end up at the same spot. Okay, so if I use that last one, I need the cosine of theta, which cosine of theta here is adjacent over hypotenuse. So negative 1 over 2, so negative 1/2. So then this is going to be 2 cosine squared of theta minus 1, which cosine of theta is negative 1/2. So that's going to be 2 times negative 1/2 squared minus 1. Well, that negative 1/2 squared is the same as 1/4. And then 2 times 1/4 minus 1. Well, 2 times 1/4 is 1/2 minus 1, which is going to give us negative 1/2. This was just a coincidence. Like I picked this just randomly, and that's just a coincidence. Like, don't count on that always happening. But that means the cosine of double this angle is negative 1/2. Okay, and you'll get the same thing if you did it with that top one or if you did it with the second one. Okay, questions with that one? Okay. So then to get to half angle identities, so half angles are, it's the same concept, but now instead of finding like the double angle, you're just finding half of it. And notice we have a lot of these plus and minuses here. To determine the sign, you have to determine like which quadrant it's in. So you have to use like the all students take calculus thing to see, well, if it's in the first quadrant, everything's positive. Second quadrant, sine's positive, third's tangent, and fourth cosine. So if we look at this, if we're finding cosine of 105, and the reason we're doing the half, you have to use like this theta over 2, because 105 isn't on the unit circle. But if we double this, oh wait, before we double this, 105 is in the second quadrant, which means sine is positive there, so cosine is negative. So whatever our answer is, it's going to be negative. So when we're doing the plus and minus, it's just going to be the negative part of it. And then 105, if I double that, that's 210. 210 divided by 2 is the same as 105. So that's the reason we can do that. And 210 helps us because 210 is on the unit circle. Okay, 210 would be right here. And we could find cosine of 210 easy. It would just be negative square root of 3 over 2. Okay, so if we go through this, we have cosine of 210 equals negative square root of 3 over 2. And I need that. Notice all of these use cosine. Tangent use sines and cosine, which makes sense, but all of these use cosine. So cosine is negative square root of 3 over 2. So then here, cosine of 210 over 2 is the same thing as negative square root, and it's negative because it was in the second quadrant, of 1 plus the cosine of theta, which theta is just 210 divided by 2. But we know what the cosine of 210, it's negative square root of 3 over 2. So I'm just going to plug that in for that cosine of 210 right there. And then this is just algebra. Now we just have to simplify this down. So that's the same thing as 1 minus square root of 3 over 2 divided by 2. We can get a common denominator on the top there of 2. So that's the same as 2 over 2 minus square root of 3 over 2, all divided by 2. So if we subtract those, that'd be 2 minus the square root of 3 over 2 divided by 2. And since we have this fraction in a fraction, I'm going to change it to division. So I'm just going to put like that's divided by 2, which would be the same as multiplying by 1/2. Because whenever you do division, you can flip it and multiply. So that's the same as multiplying by 1/2, which then 1 times 2 minus the square root of 3 is just 2 minus the square root of 3. And 2 times 2 is 4. So this right here is our final answer. And I know there's like a square root inside a square root. That's okay. Just leave it like that. Okay, questions with that one? And I don't want decimals. Like this is what I want. Okay, I don't want decimals. You can check yourself. Like if you plug cosine of 105 into your calculator and you plug this into your calculator, you should get the same number. Okay. Questions on that? Okay, so tangent of 9 pi eighths. I always change it to degrees. Always change it to degrees. So multiply by 180 over pi and you get 202.5. So this is the same as tangent of 202.5, which 202.5 is in the third quadrant. Third quadrant here. And tangent is positive here. And so if you use this one, you would use the positive part. I didn't use it. And I usually, when I do tangent, I use one of these two. Just because if I don't have to deal with the square root, I don't want to. So if I have other options, just a way to check yourself here is that my answer should come out positive. Okay. So 202.5, that's the same as 405 over 2. And I just got that by multiplying this by 2. Which 405 isn't on here, but I bet that's not an angle between 0 and 360. So if I just take that 405 and subtract 360, and you get 45, that's the coterminal angle there. So that means the tangent, oh, this is in the first quadrant, but the tangent, wait a second. Ignore this. This is wrong. That first quadrant thing, it's in the third quadrant. We just talked about it. And it's positive in the third quadrant. Ignore the first quadrant stuff. But tangent of 405 is the same as tangent of 45. Okay, is there any questions to that part of this? Okay, so here, I'm going to use this one. And you could use this one. You could use this one. Just know that it has to be positive because it's in the third quadrant, not the first quadrant. But tangent of 405 over 2 is the same as 1 minus cosine of 405 over sine of 405. But 405, cosine of 405 is the same as cosine of 45. And sine of 405 is the same as sine of 45 because they're coterminal. It's the same thing. Okay, and if I look here, 45 degrees is right there. The sine of that is square root of 2 over 2. The cosine of that is also square root of 2 over 2. So I can replace those with 1 minus the square root of 2 over 2. And that's going to be over the square root of 2 over 2. And then again, this is just algebra from this point. So we have to get a common denominator on the top of 2. So it's going to be 2 over 2 minus square root of 2 over the square root of 2 over 2. So that's 2 minus the square root of 2 over 2, and then square root of 2 over 2. A lot of 2's. So since we have these 2's right there in the denominators, you can just cancel them, and you're left with 2 minus the square root of 2 over 2. And I didn't rationalize that. You could rationalize it if you wanted to. For like all this online stuff, I'm not going to make you. Just leave it right there. Okay. And you would get the same thing if you plugged it into this one. You would get the same thing if you plugged it into this one. Any questions on that? Okay, this one. So sine of theta is 40 over 41. And it's between pi halves and pi. We want to find tangent of theta over 2. So that means it's in the second quadrant from this right here. And tangent is negative in the second quadrant. Now I care about the tangent because of we're finding tangent of pi halves. I know they gave us sine, but we're finding tangent. So that's why I care about tangent there. And tangent is negative in that second quadrant. And then to like fill out this triangle, well, here's theta. Opposite is 40. Hypotenuse is 41 because sine is opposite over hypotenuse. If you use Pythagorean theorem here, so you have to use Pythagorean theorem a lot with these, you're going to get that this measure right there is 9. And it's negative 9 because we went back into the second quadrant. So you went like negative on the x-axis, which makes that negative. Okay. So then if I'm finding tangent of theta over 2, I can use any of these, and I'm going to use the last one. I think last time I used this one, so let's use this last one. You could use the first one. Okay, it doesn't matter. But if I do this right, I'm going to get a negative number as my answer. So I know sine because I need sine. I also need cosine. So cosine of that is negative 9 over 41. And then if I plug that in, so that's going to be sine of theta on top, which is 40 over 41. Over 1 plus cosine of theta, so negative 9 over 41. And then just algebra. We're just doing algebra now. So that's the same as subtracting. Get a common denominator on the bottom, so 41 over 41. The top is going to stay 40 over 41. The bottom is going to stay, did I do something wrong here? Anyways, the bottom is going to stay 32 over 41. Those cancel, leaving me with 40 over 32, which is 5/4. And what is wrong with that? This should be negative, I think. Ignore this part. This is right. Like I went through these steps and I'm pretty sure I checked it, but there's something weird going on right here. So, but this is how, like, if you get this problem, this is how you would do it. I'm just confused right now. Oh, wait. It's because, so we started this in the second quadrant. Well, half of that would be in the first quadrant, so everything is positive there. Don't worry about too much of that. I wish we were in person. I could explain this further. So ignore this part right here. Okay, that's where theta is, but the half angle is in the first quadrant, not the second quadrant. Okay, is there questions on this one? No. Okay, so that's the last one I had. And I took these, they aren't exactly the ones from your homework, but they're very similar, like the ones on your homework. Okay, so the homework today is kind of the same as last time. And I do want to show you, I put up an answer key from last time. It has Mrs. Gilligan's work on it, not my work, but it is correct. She does it the same way. This is honors. So if you go here and then go to modules, go down. Here is the answer key. And they're just JPEGs, so just click on it. It's just a picture. But there's those, so you can check your work. I know it's kind of frustrating that you don't know if you're getting the right answers. But then here, same exact thing. You can either email me it or just upload it onto here. But this is the day 3 assignment. And these are very similar to the ones that I just went through with you. So there's only 12 of them. See if you can do them. If you get stuck, definitely ask me questions. You can email me. I'll answer back. I'm probably going to stay on for about 10 more minutes. And if no one else stays on, I'll get off. But that's about it. I hope you guys are doing all right with all this craziness. But yeah. And then I'm going to stop recording this.